Good afternoon, sir. Welcome.
Good afternoon.
Yes, sir. Okay, so learning for next generation engineering applications. I welcome you all on the day 6th of our 6-day FDP, and I have our expert, Dr. Akshay Kumar Nayak, sir, with
Thank you, ma'am.
participants can know little bit, session. Mr. Akshay Kumar Nayak, sir, General Manager at Bhilai Steel Plant Sale. He has over the 24 years of extensive professional experience in quality management and regulatory compliance within the organization. Mr. Nayak's wide-ranging experience and leadership in managing the industrial processes are adapting to digital transformation and technology. The industry use cases of AI. His session will help us explore how artificial intelligence being applied across the various support the data-driven decision making. We extend a warm welcome to you, sir, and we look forward for an enlightening and thought-provoking session. So once again, welcome, sir. Yes, sir. Sir, if you are ready, we can start the session now.
Yes, I am ready. As
Yes, sir.
you,
Yes, sir.
I will again
Thank you.
all participants. As ma'am already said, myself Akshay Kumar Nayak. I am working as a general manager in merchant mill of Bhilai Steel Plant.
Okay. Yes.
I have served there for last 30 years. Uh, I am working in Bhilai Steel Plant India Limited, sale,
Yes.
and it is an integrated steel plant. Uh, we deal starting from raw materials to the finished products. We have blast furnaces for converting iron ores to hot metal. We have basic oxygen furnaces. There we convert hot metal to steel. Then we have continuous casting shops where we produce blooms and billets. And we have finished product mills. We have rail mill, plate mill, and merchant mill. We have wire mills, bar and rod mills. You all might be knowing that Bhilai Steel Plant supplies rail lines to Indian Railways. We are the only producers.
Yes, sir.
As I am working in uh, merchant mill produces TMT bars that you might have seen used in construction sites, uh, angles and channels you might have seen in fabrication shops. Of course, Bhilai Steel Plant produces them in large scale and of bigger sizes that you might have seen. Uh, if you permit, we'll start the presentation.
Yes, sir. Yes, sir.
Okay, I will share my slides.
Yes, yes.
Well, again, welcome to in steel industry and more specifically in Bhilai Steel Plant. The outline of my presentation will be like this. What is industrial digital transformation? The key technology, AI and machine learning in my steel industry, and few case studies we'll discuss. We'll discuss these AI fundamentals. Then we'll go to the case studies. First of all, digitalization. How do you define digitalization? As you all know, the first thing is digitization, video files. Uh, that is digitization. Now coming to digitalization, that means serve customers more efficiently. That is one aspect of digitalization. And what we an organization converts its entire business model and operations using digital technology. For example, changing the whole business model. Amazon transform retail integration is an evolution. It is about bringing and value creation and businesses by optimizing our process flow. The key technologies driving industrial digitalization transformation. Uh, in very short, it is IoT, connecting smart devices and machines that we will discuss. Big data analysis, deriving insights from large data sets. AI and ML, automating processes and predictions. We'll be working only on these predictions. Now, understanding key components of digital transformation, artificial intelligence. That means creating smart machines that mimic human behavior. In our plant, we are using artificial intelligence to replace human behavioral observations. The job done by human beings, we are trying to be taken over by artificial intelligence. Machine learning, deep learning, it is building models based on training data for prediction. As you know, AI and ML in daily life, you name any field, it is there. Like you name finance, gaming, astronomy, healthcare, transport, agriculture, education, e-commerce, robotics. A very interesting AI manifestation that I was very fascinated. Few years before, I was writing an email and I wrote the subject but forgot to attach the attachment file. And when I sent that, this message popped up. Like it seems like you forgot to attach a file. I was very fascinated and astonished that AI is operating in the background to help us in our daily life. If you are forgetting, then somebody is reminding you that there is a mistake. Similarly, a few months before I experienced a new thing. I had a flight ticket to Bhubaneswar and I had booked my ticket in Indigo, but I never scheduled any alarm. But alarm automatically came in my mobile that there is a flight, you should be ready for that. So this way, in daily life, you might all have experienced the marvel of this engineering, the artificial intelligence, or the machine learning advantages. Now coming cases in steel plant, a bird's eye view. As I told, our is a integrated steel plant. We start from raw materials to the finishing products, and every uh, process where AI can be and is implemented, effectiveness monitoring or inventory optimization, or to predict line efficiency, or to floor layout and process time simulation, equipment stoppage, demand forecasting. Like this, in every process, every field, optimize our production. Using AI and ML in Bhilai Steel Plant. We will discuss particular cases, and I request you if you the uses of to understand this, you need to understand the process takes place, the methodology, utilization of machine learning in of the merchant mill. Uh, these are 105 into 105 cross section billets reached us in merchant mill to be converted to our finished products, like these are angles and channels. We convert billets, angles and channels in our mill. But how do you do that, and how machine learning is helping us? Uh, I request you all to carefully please focus on the process. I have prepared some short videos uh, to make you understand what is going on in merchant mill. Uh, First, the billet discharge from furnace. So this is the furnace reheating out from the billets are coming out of this furnace. We have gas burners and we processing them to finished products. This is that is achieved through these roller table rollers. Uh, actually will travel. Like vehicles travel on a rolling bed. On the roller table stands that I will explain.
See the video which you have played, sir.
Okay, thank you, ma'am.
Okay, sir.
Now this red hot billet is moving on the roller table. This stand I will machines uh, at the road to the heavy duty rollers. If the cane is too thick, the roller will not take the bite. Entering this metal into this uh, roller, very large scale machines uh, to change its shape. And as you know, this is not a sugar cane, this is a steel billet. It becomes very, it undergoes plastic deformation. If you press it, the cross section will change. If cross section will be smaller, naturally the length will increase because of the constant volume principle. Uh, when you roll it, the length increases and the cross section or the thickness reduces. These are rollers, and one by one it will pass through, and there is one more stand or a road through which it will change its shape and size. Road is not straight. Bends and turnings, like the metal comes from this mill, because you should know the contour of this applied. Before turning and the metal stand to other through it, you can see after here there is a water splash, and final product will be full. The final product, it is moving. These are lines you can see. The final product is getting collected, bundled into different bundles, and it will be shifted by crane, and it will be sent to the destination through Indian Railways. So this is the process done at the merchant mill. And now it must trigger your mind examples. If anything comes to any participant's mind where we can improve the process by applying machine learning, may please share. Anybody who can think well?
गुड आफ्टरनून सर।
Good afternoon.
सर अभी आप वो जो बेंडिंग की तरफ बता रहे थे वहां पे भी साइज है या जो शेप में अपन ड्रॉ करना चाहते हैं उसको उस पर्टिकुलरली डायमेंशन के बाद हम मोल्ड कर लें।
Yes, you are very close. Uh, how to turn this and how to mold this? That is a question. And what are the problems that we are facing? You have rightly pointed out there is a turning, means there is a danger, and there is danger in road also, straight road.
जी सर।
Thank you. Again, this is a mimic panel that I have explained. Uh, you can mark my mouse pointer. These are the furnaces, and the hot metal comes here on the roll table. It passes, when it turns here, it turns and again passes through this and straight road to this stand. Okay, the first case implementation of merchant mill, that is couple early detection or prediction. Couple, what is a couple? Couple is a metal accident. As you ma'am told, there are bends and different, there are two bends and two, three straight line movements, and it moves in pipes also inside the water chamber, water filled pipes. So there is possibility of accident, and there we use AI to predict well before so that it can be avoided. I will give an analogy, one more video. Well, this is a road accident incident. A two-wheeler is moving on a road and accident is caused. There can be various reasons. There can be excessive overspeeding, or the man could have been under the influence of alcohol, erratic movement, or there may be some friction issue on the road. Just I am explaining, you have to think of the different parameters in my rolling mill on the roll table path. Any change in one parameter will cause accident. That is known as couple. Couple means if this metal is stuck up somewhere, I will show you one picture. You see, uh, this metal should have moved smoothly, but it is stuck up here. Once it is stuck up here, the previous stand is pushing metals because it is rolling. So this is getting entangled here. The whole rod, red hot rod, is getting entangled. This is known as couple, and this is very costly for us because you have to remove this by cranes. You see, this is one sort of couple also. That means uh, it is not moving in a desired path that we had designed. It deviated. This is path deviation. Machine learning identify the pattern of the path of the metal, and if any deviation is seen, it is supposed to make decision and generate an alarm because a couple is going to happen, so that operator can stop it. So that these metals uh, that I had shown in video, that was moving at a slow pace, at a slow speed, but actually it is running at a very high speed. Uh, but there is no gap. There is only 2 to 3 seconds gap between two metals. So you can think of the speed around being produced, and it is moving at a very fast rate. Earlier, human being used to watch the movement of these metals, how this is moving. You might have seen it. It is moving like a snake at a very high speed. Uh, but we had the experience that if there is a slight deviation, some time this deviation will increase and there will be accident or a trouble will be formed. So how machine learning is doing this? Is doing with the help of cameras. There are 12 cameras. They are monitoring the path of this motion, the movement of, and the program used is Python. Uh, I myself am not very conversant with Python, but we are interested in the end result. If there is a slight deviation in my metal in its predetermined path, then it should give me a alarm, or it should give a pop-up that it has started deviating, so that before accident happens, I can stop the mill or I can change some parameters like speed, like heat, so that the original pathway is preserved. So the simple methodology is path deviation, and you can see how they are doing it. They are deliberately keeping this dark background to show that the metal moves in like this. And machine learning is collecting these paths for last 1 year, and we have achieved 98% success. That means 98% times it is able to tell that this path deviation is there and the trouble is going to happen or accident is going to happen well before time. But there are still 2-3% left. We need 100%. So there is zero tolerance on this, and for that machine learning requires gathering of data for 2 to 3 years, because there are different products. This is not only a TMT bars, there are different products. In the same path, angles and channels will also move. So there will be different set of data, huge amount of data of this pathway, so that they can predict it 100%. These are the comparisons that we generally do. The simultaneously human being is also observing the movement, and is checking whether computer is also, or the artificial intelligence is also detecting or not. So we are, in most of the cases, we are finding that human being is observing there is a slight deviation, and machine learning software or AI is also observing that it is detected. These are different slides showing the path, how the designers predict the pathway. The pathway defined at the bend, and there is a slight loop here. You can see this is also taken into account. As I had explained, there are two rollers. There is one roller in front and there is other roller at the back of it, and the metal is simultaneously gripped by the two rollers, and they should run at the same speed. If someone is slower, if the front is slower, then there will be a bulge like this, and the slow speed of the rollers is attributed to the slow speed of the motor, and motor has got its one control system that you know. These are different slides how successfully it is being done. This is the desktop screen to monitor how trouble is being detected at what camera, at what position. So the summary of improvements and completion of this MI AI project is trouble prediction or early detection by path deviation, by intermetal gap reduction. Once there is a prediction, the operator will do all these things. He will reduce the intermetal gap reduction so that accident or trouble is avoided, by metal loop formation, by metal slowdown, by metal stop. So all these things uh, are being done case study in the same merchant mill. This is about computer vision based bar or angle or channel, or how many angles are there in this bundle. There machine learning is being applied, and it is again computer vision based based on cameras. There are again 10 to 12 cameras for this. Here industrial 4.0 architecture is used. As you all know, there are 3 tires. Edge tire that includes your cameras and sensors. The platform tire where we have the uh, computer servers, data storage, analytics, and the enterprise tire where the application used. How we see it in the computers. Uh, Here it may take you some time to understand, but simply you go by the position of cameras, uh, how this counting system works. You can mark my mouse marker arrow. Here the finished products are there. I had shown the video that the finished TMT bars are coming on the rolling mill to be collected at these collection cups. So while coming, there is a camera here at bay 248. It counts how many are there and how many times such how many batch of TMT bars came here and was collected here, and after bundle formation it was lifted from here. So we are counting the number of bars. Earlier this was done manually, but as I had explained that they are happening at a very high speed. It was manual counting was also erroneous. Of course, this ML based counting is also at 99%, not 100%, because of some operational issues. But again, 10, 12 cameras are used here, and they are watching all the movements of the TMT bars and counting the number of TMT bars in a bunch. You can see our operators always see like this. Those who are counting manually. You can also count 1, 2, 3, 4, and this is also for last 6 months they are doing it, and in 99% case they are telling it is okay. At the first sight, it may seem very small issue. Anybody can count what is the problem, but just think when there are not these 4 rods. Suppose there are 32 rods, 14 rods, then manually always. Correctly. Sorry. So these are the counting stations, the monitors located at different positions, and every time we are checking it whether our human being is checking it whether the machine ML system, machine learning system is counting it properly or not. When it will be 100% correct, we will remove human being from these posts and will reduce the human intervention. There is a sensor. This is a simple laser-based sensor. It is for zero setting. Like when bundle is lifted, there is nothing. This ray will one bundle has been lifted from that cup. This is one way of counting bundles. So there are 2 systems: counting number of rods and counting number of bundles of TMT bars that is being produced and being shipped. Percentage of accuracy. As I told when it will be 100%, then it will be declared successful. But it is under progress. These are again some snapshots at different camera stations. So this is all about some hundreds of such projects being undertaken, and we will also discuss a few implemented artificial intelligence use cases in different software.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Henceforth, uh, there is no time. We cannot go in very detailed process understanding as we have done for the merchant mill. For others, we will go in a short way. The first one is coke quality prediction using AI. Now, as I told, we are an integrated steel plant, and we convert this iron ores to hot metals, and for that we use blast furnace, and for blast furnace we need coke, and coke is coming from coals uh, by using coke oven batteries. But the coke quality is very important. Uh, that we need prediction. Uh, why? Because only one type of coal is not available in market. We procure coal from Australia, from Indonesia, from our own Coal India, Mahanadi coal fields. So there are different sources of coal. And for that we need blending. Blending means mixing of coals, of different types of coals to achieve optimum cost and to achieve optimum quality. That is known as blending, coal blending. And we need, while doing coal blending, means mixing uh, different types of coals. Uh, I hope I am explaining blending in a proper way. Uh, like you think about garam masala. Garam masala means what? It has many ingredients like cinnamon, cardamom, uh, coriander seeds, cloves. When you mix together, you get a very good taste, a very good flavor of. We mix them up uh, to achieve optimized cost and to achieve optimized quality. So as shown here, coke is main ingredient for reducing iron ore to iron acting as a source of heat. Coal from different sources of different qualities are blended to obtain optimum quality and cost of used coal. Coal cost accounts for approximately 53% of total steel making cost. And now it will be very clear to you why we are interested in coal mixing, because it is a very costly affair. Blend preparation to coke formation. Coal blend preparation is done through mixers. They supply material in a mixed manner. So that is coal blending, and but we need to predict the quality of the coke. What will be the quality of coke? Uh, and there will be no mistake. Machine learning will help us. For that, different analytics uh, is being done. Large data is being gathered, and we have developed a model for that. Before we will come to know, after processing, what will be the quality of the coke that we are getting, whether it is suitable for or not blast furnace, whether it is of good quality or whether it is of optimum cost. Now, process interventions can be taken based on model predicted quality to obtain high quality coke. This is again a desktop uh, design of coal blending machine learning strength. Uh, what will be the coal strength, whether it is suitable or not, and what will be the blend cost also. That it's simple. If sufficient data is given to this machine learning system, and machine learning system is monitoring the input material and monitoring the output material. Process in between. Definitely the product will have these guaranteed properties. This is the same again. There are different analytics from available coal resources. Automated recommendations for optimal quantity of different available. It gives alarm, change your coal mix, sort of like that. It gives uh, messages. Assisted decision making scenarios of limited raw material availability. And this is about coal blend optimization. Intelligence, you might have seen it in many places. Now chatbot has taken over all the industries. So I am moving forward. It is very exhaustive. You can question anything and AI will answer. That Google, like Google is doing whenever you go for a search. These are automatically as per the AI design. Now some analytical interventions. It is in the preliminary stage in different shops like coke oven battery. Analytical interventions, that is also part of AI. That means artificial intelligence. That is regarding coal blend optimization. Feed the least cost coking coal blend to coke ovens, which will help achieve desired quality and throughput parameters that we had already discussed. Digital twin for coke ovens to optimize coking coal blend, achieve quality parameters, and help operator work in optimal operating regime. Coke oven asset health optimization. This predicts coke oven health. Refractory materials have the linings in the coke oven that gets damaged over a period of time. Some other day I will explain the details there. It can also predict the health of refractory thickness as it gets reduces. Sorry. Then, as I told, the coke strength prediction and control, that is CSR, recommend optimal air to fuel ratio in hot blast stoves based on historical data to increase hot blast temperature and reduce coke rate. Emission optimization, recommended adjustment in operating parameters such as adjusting coal blend, optimizing heating and quenching schedules, etc. to maintain SPM emissions within regulatory limits. Now a few analytical interventions in blast furnace also. Project recommend optimal air to fuel temperature and reduce coke rate. These words hot blast may be alien to you, those who are not conversant with blast furnace. But you just think artificial intelligence is helping in what way, in up to what level in a blast furnace. It is used in carbon rate prediction. It is used in burden recommendation model. It is used in 2-year health analytics. 2 years are the pipes through which hot blast is sent to the blast furnace. Drilling assistance model, recommend operators with appropriate drilling diameter, mud machine setting, basis lining condition, HM temperature, etc. Actually, Bhilai Steel Plant has kept some key performance indexes, KPI. Intervention will be successful if coke rate is decreased by 1.1 to 1.5%. Fuel rate is decreased, means the efficiency will increase. Naturally, you can understand. Flux consumption will go down by 1 to 2%. Blast furnace production will go up. Naturally, if artificial intelligence is successful, then critical consumption will decrease. So these are the critical key performance indexes that is being monitored while artificial intelligence or analytical interventions are being implemented. When this will be successfully and complete. Sinters are also very important, like coke. We need a sinter in blast furnace. Actually, blast furnace input materials are your raw materials, iron ores, the sinter and the coke. They all go to the blast furnace, and finally hot metal, iron hot metal comes out, pig iron comes out. So that is the process in the blast furnace. And sinters are produced in sintering plant. So in sinter plant, as it is a key input, it is very important to monitor its quality. So analytical interventions are also done there. Excuse me. Okay, thanks. Here also the key performance indexes will be the blend cost should go down, the solid fuel consumption should go down, flux consumption should go down, and the quality and the performance should increase. Analytics interventions include input material mix recommender. It recommends optimal mix of input materials, iron ore, coke, breeze, flux, to minimize raw material cost while meeting blast furnace requirement of quality and quantity. Here also the same here blending of iron ore, coke, breeze is also done at sintering plant to get the desired or expected quality output. Return fines reduction. Recommend operating regime such as solid fuel flow, machine speed, cooler pressure, etc. to reduce internal and external sintering. Then it will not be rejected. Return means it has been rejected and it has been returned back. That means the quality of the sinter produced is not up to the mark. And why it is not up to that mark? Here, our machine learning analytical interventions system is helping us to take the corrective measures so that the center return fines quantity is reduced. Similarly, it predicts center output, RDI to control it through adjustment of operating parameters like machine speed, wind box pressure, flame front, etc. To analyze historical data on equipment failures and maintenance events to predict potential failures in advance. Stack emission optimization, here is also emission has become a big issue now. So predictive models are required, and that is being provided by artificial intelligence. The predictive models to recommend appropriate input material mixes, operating regimes, and other parameters to minimize emission of particulate matter, PM, and productivity. This project is also being taken at sintering plant. Now, one more project in SMS and caster. SMS means steel melting shop, or you can name it pig iron is produced in blast furnace. That is not steel, that is simple iron. And that hot metal comes to basic oxygen furnace. Here is the basic oxygen furnace. You can mark my mouse arrow. In basic oxygen furnace, few other metals like silicon, dolomite is added to convert this pig SMS. And degassing is done because if gas is entrapped in steel, then the quality will be destroyed. Caster means here the hot steel or liquid steel is converted to solid billets and blooms that we had started in the beginning of this presentation. Now this is solidified over a period of time, and when this solidified steel reaches to these in different modes. Before that, it was liquid steel. The solid steel, uh, that blooms and slabs are fed into different mills. For example, slab goes to plate mill for producing plate. At those places, at a steel melting shop and at caster, different AI projects are also being taken. And the key performance advantages and the analytical interventions are ferroalloy consumption optimization that recommend optimal process setting that have resulted in optimal consumption of ferroalloys in the past for a specific steel grade and hot metal properties over a long period, and it advises you or recommends you to add the right quantity of ferroalloys. So these analytics desktop at our end, we see different proposals, recommendations given by endpoint properties from blast furnace, basic oxygen furnace process parameters, hot metal properties, and prescribe operating regimes to ensure achievement of endpoint properties and avoid reblows. Because if quality is bad, again we have to blow it. That is reblows. Casting speed maximization. Here also it recommends, AI recommends maximum casting speed. Speed basis chemistry. Speed means, as I told, at what rate you are moving this bed. This you will understand this hot metal will spilled away. So you need a optimal speed because we want to remove this stopper, ensuring that it is sufficiently solidified. Otherwise, this hot liquid will spill away. Speed basis chemistry and heat parameters for throughput improvement without impacting reliability and operator confidence. A reduction in caster nozzle clogging, that nozzle through which hot metal falls. It recommends optimal setting to reduce clogging caused due to resultant mold level fluctuations. Improved LD gas recovery, track LD gas recovery of individual heat to highlight any instances of violation of SOP so that root causes of generally generated during basic oxygen furnace are very toxic and also it is flammable. It is used to this there also AI laid out so that AI is declared successful. Now in some other plant of ours, we have automated zinc coating control using machine learning. This is a metal strip on which zinc coating is to be done, and it is done through a nozzle, and it is the machine learning recommends the distance so that uniform thickness of zinc is coated. Machine learning based zinc coating prediction model based on critical contributing parameter variations, multivariate logistic regression model to compute real-time zinc coating weight, integrated the model prediction into shop operator screen. Everywhere they are giving us this screen. Whatever prediction, whatever recommendation they are giving, the AI gives, it is naturally should be available to the operator so that he can act as per the recommendations. There is one AI based silicon prediction model in blast furnace. Silicon prediction model ascertains the thermal stability of the furnace and helps in identifying potential issues before it becomes critical. Actually, this is one of the blast furnace parameters. For example, sulfur content in the hot metal should not be more. If silicon is more, then uh, blast furnace will lose its thermal stability. So these parameters, even the chemical parameter, at what level AI is going, you just think. Uh, the silicon content parameter is also being monitored by AI, and it gives necessary recommendations so that the blast furnace works in a healthy manner. Dynamic nature of blast furnace with numerous variables affecting silicon levels complicates accurate prediction. That's why AI comes to play. Neural network based model for predicting silicon level 1 to 6 hours in advance. Uh, Naturally, if you get advanced prediction, advanced information, then you can act to rectify it. So this AI project is taken machine learning projects that are undertaken in Bhilai steel plant that I have shared with you, and some future of industrial digitalization technology that is in the movement to explore uh, artificial intelligence. That's all from my side. Uh, Thank you very much for patient listening. Now the house is open for any question or any words of wisdom.
Thank you, sir. Any queries from the participants? Okay, I think there is no
Well, if
queries.
it is okay, then let's call it a day.
Yes, sir. Yes,
Some other
sir.
day, I will come up with some more visual uh,
Yeah, yeah.
explanation of different shops of light.
Thank you so
Status
much,
of
sir.
AI has
Akshay
truly
sir, thank you
enhanced
so
our
much.
understanding.
Thank you, madam. Thank you.
Real-time applications and the videos inside the sale. Yes, sir.
Thank you, madam. Thank you.
So on the behalf of the time, effort, and dedication you have shown in sharing your knowledge and experience with us, and yes, as the ma'am said, your examples from real industry scenarios may have helped to bridge the gap between academic learning and industrial practice. So thank you so much, sir, for giving your valuable contribution to this FDP, and we hope to have many more such insightful interactions with you in the future. So thank you so much, sir, for joining with us.
Okay, thank you.
Very nice session. Thank you, sir. Thank you.
Thank you, sir. Thank you so much.
Okay, I'm sharing the feedback link for today. Wait for a few minutes. Okay, give me a few minutes. I Okay, sorry. Okay, so participants, I have one announcement to make, and sorry to share that our next expert, who is Dr. Rajiv V. Dharashkar, sir, who is Director and Professor Triple IT Kottayam, Kerala. Sir is busy in a meeting in the PM office, Delhi, meeting with the PM secretary. Uh, Sir was in the morning. He has given his consent, but he is not free till no time. So, and he's busy in preparing the new protocol with information technology with our PM. So that's why he is not able to take lecture currently at 3:30 p.m. So sorry to share this that we can't take. There is no session now for the 3:30 p.m. session is cancelled, and so we will meet for the our next session or the last session of the FDP at 5 p.m. sharp. Mr. Vivek Verma sir will join with us as an expert speaker. Okay, so there will be no session now. We understand that sir is busy in PM office Delhi, so um, the this lecture or session 3 at 3:30 p.m. is it's not possible now because sir is busy. So we have to cancel this session. So I hope you all understand. So
Yes,
okay,
ma'am.
okay, okay. Thank you. So we will meet.
No
So
matter.
the
Ma'am, I have some questions.
yes, ma'am.
ये वाला सेशन नहीं होगा तो फिर जो नेक्स्ट सेक्शन है वो 5:30 से होगा
5 p.m. पे मैम 5 बजे.
और फिर 5 p.m. जो होगा वो लास्ट सेशन रहेगा उसके बाद ही क्विज होगा कि
हाँ,
वो
उसके
कंप्लीट
बाद
होने
क्विज
के
होगा
बाद
मैम
ही?
6:30 p.m. पे ऑनलाइन टेस्ट और जो फीडबैक फिल वाला है, तो
हाँ
6:30 पे टेस्ट वाला. ये वाला जो सेशन है 3:30 to 5 p.m. स्लॉट है वो अभी फ्री है.
हाँ
नेक्स्ट सेशन 5 बजे होगा मैम, क्योंकि सर हमारे यहाँ न्यूयॉर्क से जुड़ रहे हैं,
जी जी जी
तो हम
ठीक है
शेड्यूल
मैम
अभी इंटरचेंज नहीं कर रहे हैं.
हाँ मैम ठीक है
जी
जी
जी जी.
मैम एक और चीज पूछना था मैं
यस
आपको
मैम.
पर्सनली कॉल कर लेती हूँ ठीक है
ओके 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 ओके, नो प्रॉब्लम मैम.
ठीक है ओके थैंक यू मैम
यस, थैंक यू मैम. Okay, so we will meet at 5 p.m. sharp evening for our last session of our 6 day FDP. The topic will be the expert will be Mr. Vivek Kumar sir, who is from New York based AI entrepreneur enterpriser. So we will meet at the 5 p.m. sharp. No, or also I want to share that after that session we will have our online test and feedback, and at the 7:30 p.m. we will have our valedictory session of our FDP. So thank you for joining with us. We will meet again at 5 p.m. evening for our last session of FDP. Thank you everyone. If you have any doubt, we can discuss in the WhatsApp group also. Thank you. Okay, welcome once again to our Atal online 6J FDP program under the title Emerging Frontiers in AI and Machine Learning for Next Generation Engineering Applications. Now it's time to proceed for our last session of our FDP. And today's our last session, which is session number 13. And we have our speaker, Mr. Vivek Verma, sir, with us. And sir, it's my great welcome, sir. Hello, Mr. Vivek Verma, sir. So welcome.
Hey, hello everyone. Hi, Swati.
Yes, sir. So it's my great pleasure to introduce our distinguished expert speaker for today's session, Mr. Vivek Verma, sir, who is program director at Orion Code. He is a New York-based AI researcher and entrepreneur who is actively involved in startups developing the product-grade generative AI systems and also conducts the industry-focused AI masterclasses. Mr. Verma brings with him a wealth of experience from his prior roles at leading organizations such as Toyota Connected, PwC, and IBM Watson. He currently leads the startups working on cutting edge technologies like agentic LLMs, retrieval augmented generation RAG, and verifiable AI, which bridge the gap between the research and the real world applications. Today, Mr. Vivek Verma sir will be speaking on a highly relevant and fascinating topic from prompts to products, applied generative AI for faculty with real case studies in healthcare and the insurance. I know his talk will explore how generative AI is being used beyond experimentation to create the practical, production ready solutions in critical domains like healthcare and insurance, and offering the valuable insights for both academic and the industry professionals. So, on behalf of the organizing committee and Sri Shankaracharya Technical Campus, I extend a warm welcome to you, sir, and we look forward for an enlightening and engaging session. Thanks for joining with us, sir.
Thank
Welcome
you. Thank
once
you for
again.
this introduction, Swati. By the way, it's still 6:30 in the morning for me, and I
Oh,
haven't
yeah,
had my
yeah, yes,
coffee
sir.
yet.
There's a
So
huge time difference.
pardon my appearance, and also this background which you are seeing. It's a virtual background. It's not my real. I'm actually
Yeah.
speaking from my home office.
Okay.
It's Sunday here, Sunday morning. So
Yes, sir. Yes, sir.
okay, so we can get started.
Yes, sir.
So what I've done is that I usually speak at
Sorry.
conferences and meetups where most of my audience are startup founders or investors which are looking to invest in cutting edge AI technologies. On the other side, I also train and mentor the developers and other people who are looking to build their own generative AI startups. So in that capacity, I provide them technical understanding and a lot of hands-on skill sets in that area. I wasn't sure what type of audience will be joining. So what I did was I integrated a mix of little bit of technical, but more on the business aspect. And then towards the end, I actually kept a couple of case studies, which I'm going to live demo. So I split the entire session in three parts. First, I'm going to just talk about some conceptual understanding and some business applications. We'll take a 5-minute break. I'll set up my computer ready. Then we'll start with a case study on healthcare, where I'll show you content generation using large language models. And then we'll take another 2 to 3 minutes break. And then I'm going to talk about a case study on agentic workflows using multi-agentic systems using MCP and A2A for insurance application. So that's how the process will flow in this session. Roughly, it would take slightly an hour or more. We'll see how the pace goes. I would encourage in the first section, when I'm discussing theory, if you have any question, you can raise your hand or unmute and ask me. If you have any question on the demo, you may wait until the demo is finished, because I'm going to explain the high level and then we will dig in the live. So if you have any questions, feel free to wait until the end of the demo and then you can ask me, and then the same goes for the third section as well. So that's how the process will go. So let's get started. Good morning from New York and evening in India.
Yes.
I'll share my screen now.
Yes, sir.
So I hope can share my. You can see my screen. Let me know when you guys can start seeing my screen.
Yes, sir. Yes, sir. It's
Are you
not
able to see my
visible
screen?
now. Currently, it's not visible.
It's not visible yet.
Yeah, now it's visible, sir. Yes.
Okay, excellent. All right, so you guys can see this presentation.
Yes, sir. Yes, sir.
Okay, excellent. So this presentation is created in a software called Gamma.ai. If you are looking to check it out after the present distribute,
Yes.
whoever is looking for it.
Yes.
So we can get started meanwhile. So as I mentioned that I didn't had a specific topic to discuss, so I just created a mixture of concepts and some technological nuances. The era of generative AI actually started in 2017 when the first paper from Google came, which is attention is all you need. A lot of people, students, faculties who are in computer science, IT, they may have definitely read this paper. So after that paper, there are more advancements which came. I'm focusing on the era of what started working in different applications of AI. Particularly, I was focused on text generation and summarization for a company, where we build a pipeline for research, mostly in the clinical domain. And then in 2023, end of 2022 and the beginning of 2023, ChatGPT came. So that was the moment which actually gave applications, basically the type of models which gave more productivity and enhancement to AI was GPT-4b. So these models like DALI, Midjourney, Stable Diffusion models, and all started creating multimodal applications. And now we call it as an era of agentic workflows, agentic AI, because you see ample amount of applications in agentic workflows, and particularly in the field of when we use MCP, which stands for Model Context Protocol, and then recently, few months back, A2A from Google, agent to agent came. So this actually helped to build a lot of applications in agentic workflows. So this is the timeline which we see in the generative AI domain applications using AI or generative AI. And then this is something which I always saw to give $4.4 trillion. In India also, I came up with some number, which is $17 billion. And it's going to go up with a 25% annual growth rate. The big thing or the best part is that we have a lot of graduates in STEM, about 4.4 million. And the reason why we are talking a lot about this is because, to give you a quick reference, it took Instagram almost 2.5 years to reach months to reach that number. So you see that there is a big gap and there is a huge potential in that, which I was mentioning in 2017, the paper on attention is all you need from Google came. So that paper I'm using, for example, GPT-based models or any video LLMs, video transformers and all, they're all based on newer applications and new architectures, which can help in small language models for edge devices like your smartphones. In this year, when the paper came, a lot of researchers, particularly in natural language processing, started building newer applications. And then after this, the word-based models came, and then it got scaling into large language models. So in the field of large language model, we talk about chinchilla scaling, which talks about, by the way, I also created some notes here, so you can take a look into it. So if you click on this, you will find some explanation, brief explanation on the topics which I'm discussing. So feel free to check that out as well. So we see that the scaling for compute efficiency actually generated or evolved a lot of different large language models. So nowadays we see every single month a new version of models come, we see that every year or in 6 months, a new variation or a new family of GPT models are also coming. So right now, if you see ChatGPT is using GPT-5, and then other companies as well, they are launching Boost in that. So if you know the field of prompt engineering has evolved into context engineering, because this is something which we are actively working on in building more and more applications using generative AI areas. First is your foundation layer, where we have the core engine, the LLMs, for example, Llama 3 from Meta, Facebook, Mistral, Gemma from Google. And then there are some proprietary models from companies like OpenAI, like GPT-5, and then Anthropic has Claude, and then Google Gemini models. And then companies like Bloomberg, with their millions and millions of financial documents in 2022 and 23, and created Bloomberg GPT, which are being used by traders and other finance folks. So we see that in multiple applications across the industry, companies are building their own. To apply this core engine, we also need infrastructure. So companies like NVIDIA, AMD, Intel, and so on, they are building compute resources like GPU clusters. So that's where your infrastructure components host the models. And then there are other applications of infrastructure layer. So for example, if you are aware of RAG, retrieval augmented generation, we save this resources and documents in the form of embedding vectors. So these vectors are saved in the softwares like Pinecone, Vweight, really builds applications. So there may be more layers. I'm not discussing about other ontology layers, but there are other layers. Frameworks like LangChain, LangGraph, Llama Index, AutoGen, and other application layers for proprietary, and some are open source as well. And then to track the performance, we have softwares like Weights and care of. And then on the business side, we see that there are three components or the three steps which are involved. The first is to look into the business data. If you are starting to build application in your generative AI, then the first thing is to look into what type of questions, what type of problems you are going to solve. And then based on the performance which you are getting, you build actionable output and interpret the results. So we see that LLMs can be worked as a consultant, which works 24/7. The cost is negligible. It's less than 2 cents per query, and it is 1,000 and more times faster than a human analyst would work. So that's the big boost or big advantage of using large language models for a lot of monotonous tasks. For example, like in service sector, in customer service, in field where we major applications and companies, startups coming and building products. Some of the key capabilities on the technical standpoint which we talk about is how to make these large language models more and more efficient. The first way is to increase more and more token size. So we talk about context windows. So now we have models which can handle up to 1 to 2 million tokens, and then the different reason the generated answer. So that happens through prompt engineering methods like chain of thought, tree of thought, and graph of thoughts, wherein they have the LLMs think what they actually explain. And then on the tools side, we do caching, function calling, and code execution so as to make it fast and reduce the latency of the result generation. In terms of multimodality, we have already made a good progress in the field of multimodality in large language models. If you are working on niche applications nowadays, so there is a technique called parameter efficient fine tuning, and there are other different types of fine tuning which are used to make this large language model more and more efficient and also specific to your data. For example, if you are into legal area or you are into insurance, then you would like the documentation to be learned by this large language models before generating the answer. So parameter efficient fine tuning using technique like LoRa, which stands for low ranking adaptation matrix, can be very useful for your application. So a combination of this is highly important in your business applications. Now, I also created some slides on the different areas where already the generative AI is making a big impact, because I also talked to other founders from Bay Area and in New York City where I live. So we see that a lot of areas, for example, saved with 3 times return on investment. Also in code development, we see a lot of software developers, engineers, they are using. And nowadays, even if we draft an email, we refine it using one of the large language model, AI assistant. So we are using it over 90% of the time for content generation and improving our writing skills. And in other areas as well, in document retrieval, where again, one of the applications which I'm building is very helpful in improving the company's performance, productivity, and providing services to different employees. So we see that many areas, many key areas are getting impacted with a lot of ROI, which is up to 200 to 300%. Now, like process automation, decision support, or innovation. So what is the level of complexity? So the 3 levels are simple, moderate. See that the document generation is the simplest task, but if you are creating autonomous agents for a scalable application, then this is something where you need a lot of skill sets and a lot of thought processes involved. And then also in innovation, we see in content generation, a lot of innovation has already happened. But if you are working into niche area like drug discovery, or if you're into physics, some subatomic particle discovery, then we still see a lot of areas of improvement. So this and what needs to be done in order to build this application. And then the areas or the domain where generative AI and large language models are impacting are more, I mean, there are more domains, but I just compiled 4 of them. In financial services, I again have worked on some areas. So for example, writing claims, there's a case study which I'm going to show, are getting automated using generative AI. And the time, the cost reduction and the time reduction is almost 10 times compared to a human intervention which is needed. In healthcare, we are seeing a lot of applications, mostly in the healthcare services. In clinical research, also a lot of applications has already happened. Some areas where still innovation are needs to be done are in drug discovery. Already built successful softwares for logistics and manufacturing using generative AI, where they are saving approximately 10. I was actually speaking to a company a couple of days back, where they are building personalized education for individual students, wherein generative AI will build different modules based on student interest areas and their strength, so that you can define their skill sets using generative AI. So this is another area where a lot of innovation is being happening right now. Some of the they already have been involved since last 2 to 3 years, wherein they have generated over benefited. Moderna, a pharmaceutical company, has built their mRNA vaccine for COVID by increased their market value by generative AI using 30% retention in the customer base. So you see a lot of applications already happening in the business side. Also, you would like to know that in marketing and advertisement, a lot of innovation has already been happening. I'm in touch with few companies which are already doing a lot of application, building a lot of applications in marketing and advertisements as well. What is the opportunity? A big ecosystem of generative AI applications in India. The reason, because a lot of software developers are actually getting trained in Gen AI, and a lot of practitioners are also getting ready with their startups. Already, India is seeing massive investments in digital infrastructure. UPI and other companies are already built successful applications. So it can be integrated for more to train these large language models and make them more dynamic. So that is this LLMs need more and more data. The cost to build an application is relatively cheaper, so that helps to fast-paced efforts. And also the government is spending crores of rupees in democratizing the AI-based application, which is also helping a massive population getting trained in this area. So now let's focus our attention to agentic AI systems. So most of the focus of generative AI right now in the year of 2025 is in agentic AI. So you may have heard of agents a lot. So let's talk about what applications do this agent do and why they are very they are used a lot nowadays compared to a standalone application in generative AI. So the bigger, so one of the main reason why agentic AI are getting popular is because like humans, they are adaptive and they are logical to perform wide spectrum of applications, meaning then traditionally you would look into flight tickets, you would look into some hotels, you would also look into some places to see. On the other hand, nowadays you can use one of the AI agent and just tell them what you want, and then it will do all this task, perform all this task for you. First, it will find the cheaper flights, it will find the right day to fly, and then it will also help you find the right hotels, right destination, and other convenience like shopping and all those things autonomously without human intervention. So as we are going in that direction. So there is a reference diagram which I created. So let's say if you are building a multi-agent architecture, then this orchestrator agent, I'm not going technical depth into the different layers in agentic AI, but there are 4 agents which you can use. I'm going to show you a demo where I'll show a little bit about this agent. Invoke 4 different agents. For example, research agent, analysis agent, executor agent, and quality agent. So these 4 agents can work in tandem, and you don't have to create hooks for each and every API. Rather, this MCP server can handle most of this requests by itself. So the AI applications nowadays. You may be thinking, how can you implement this generative AI using agentic systems, different frameworks for this application? And then for the workflow management, definitely LangGraph is something which you can use. And then, for example, if your data is sitting in, let's say if you have some financial data sitting in Goldman Sachs or Morgan Stanley, there are API available for Bloomberg also. And then these APIs can be called in your MCP, so different frequently asked questions. So this is a very general introduction on agentic AI for Gen AI applications. Now let's talk about another buzzword which has been very popular ever since the ChatGPT came, and that is fine-tuning. So you may have heard of fine-tuning. So I'll give you a contextual understanding why fine-tuning is so popular and why it is used. So when this large language models are built by legacy companies like OpenAI, Google, Meta, Amazon, and so on, they take billions and trillions of data and train a model. So that process is known as pre-training, where you train a large language model from scratch. Now, for your business application, let's say if you are building a finance application, you don't have to go through that process again, meaning that you don't need to train trillions of data sets like structured and unstructured data to perform to build a large language model. Rather, you can do a fine-tuning, which is nothing but taking a pre-trained model and then just adding some extra data which is specific to your application for your industry, and then just making it relevant for your application. So there are some performance metrics which helps to determine whether the results which are generated in your domain are relevant or not, are good or not. in a layman term. And then there is another area which is known as supervised fine tuning, wherein not only we take a small amount of data, but we also take some of the parameters or weights and we train the model, execute in such a way that the model learns a lot of new things about a particular domain. So supervised fine tuning is a step ahead of fine tuning. So you see that there are three main strategies of building an application using large language model. First, building the model by itself from scratch, known as pre-training. Second is fine tuning, which is the easiest step, and the third one is supervised fine tuning. So now, with that, we can talk about the different terms and terminologies which we use in fine tuning. So one is the complete or full fine tuning, wherein we use all the parameters and training time. It takes a lot of money. It takes approximately $3 to $5 billion to train a large language model. So it's a cost-intensive process. Then there is something known as low-ranking adaptation matrix called LoRa, wherein you take a small amount of parameters, less than 1%, and it adapts, the large language model adapts to your domain. So I was talking about Bloomberg GPT and all. So run LLM and then use your financial data and create a model for your own. Helps to train your LLM efficiently or fine tune your LLM efficiently. And then there is something known as prompt tuning. So wherein we use a set of pre-trained prompts. So when you are teaching your model, training your model of resource again, and it is again task specific. And then there is something known as retrieval augmented generation. So giving out bogus information just to complete the result generation. So this helps a lot. There is also advancement in this area. Nowadays, we use GraphRag, which is a graph version of retrieval augmented generation. And then nowadays, we also use agentic based rags, which are used wherein this agents determines whether to use rag and what type of rag to use at what process. So that is some new advancements. There is some new advancements coming in the field of rag as well. For the starter, if you are new to LLM and if you want to build an application, the best bet for you is to combine rag and LoRa. It's cost effective. It gives a good result, and then once you start getting relevant information, the results, you can improve your capacity based on the compute resources and the ML engineers, AI engineers which you have, and then you can build more and more capacity. So some of the technical challenges which we face in this field are hallucination. That it ensures that the model is not blurbing out some bogus answers results. So there are some parameters which we tune, like temperature and top key sampling, which ensures that the results which are generated are grounded if you want to make the model more and more robust. So that is where I'm actually doing research right now to build low latency small language models for video generation. So this is another area which is getting a lot of investments and traction in the field of generative AI. And then cost management, less and less resources are getting used to train the large language model because the compute resources are also getting cheaper. So this is what we are looking into it. And then data build applications using large language model. So there are different global regulations which we need to take care of. For example, in the URPA compliance, and then there are other type of compliances like California has its own compliance called CCPA. In Europe, we follow GDPR, and then in India there is something known as Digital Personal Data Protection Act, which was signed in 2023 to protect personal data and data privacy. So these are some key technological challenges which we focus and which we face when we are building. If you come from LLM development background, you may have heard of lot of different metrics, something known as task specific metric, and then there are other business metrics. So in that specific metric, you can take a look into BLUE, which stands for bilingual evaluations, a metric known as ROAS, which we use for content summarization and text summarization tasks. And then we also involve human in the loop, which is known as results which are generated are safe, and also it is unbiased. So those are all the, when they understands the results which are generated using LLM. And then some business metrics which we follow are return on investment tracking, of course. We want giving a good buck for our business. And engagement and user satisfaction are also some key metrics which we follow in business. And then there is something known as emerging trends, which we are seeing. So what is the future of generative AI? So we are seeing already multimodal native models, but then the results which are generated will be enhanced. For example, real-time video understanding and real-time video generation is still something which is a big area of research. And then 3D scene generation, like 3D Google Maps, if you have seen, 3D result generation is something which is again a futuristic version of multimodal LLMs. Reasoning will get more and more fine-tuned and enhanced. For example, you see GPT-o1 type of models getting more and more intelligent with all the data which it compiles. But with real-world applications of generative AI is another big application coming in. I know a company called Figure, which is actually building this technology. And then Edge AI, which I was mentioning, that low latency compute resources are also something which is extremely important. So there are already existing models like Gemma Nano from Google, and then Hugging Face also launched on-prem LLM. So you can check that out as well if you're interested in that area. So how you can actually integrate generative AI in academia? Because I was told that a lot of people joining this talk will be from education, professors, faculty. So I just created some timeline. So the first thing is how to integrate generative, which I have added. We can follow that to build applications in generative AI. Start with some hands-on project-based learning, and then also focus on ethics and responsible AI, and then participation, collaboration with industry always help, because you will have business problem to solve, and you will also get some data and compute resources through them. If you are looking into research focus, then definitely domain-specific fine-tuning is an area which is big in India. For example, in healthcare, education, and government services, to perform better services to the population, massive popular training. A lot of companies are already doing this. And then bias mitigation in Indian context, making it unbiased, are some areas to focus on. If students are involved, then these are the 4 areas which you can focus to get started in generative AI. First is to understand the fundamentals of Gen AI, some of the key papers which are extremely, and then based on that, you can get started into AI engineering, building scalable systems, which involves LLM ops and ML ops. So there are getting started into generative AI right now. These are some of the actionable steps which you can follow to implement the roadmap. The first is to code, and then start with prompt engineering. Then after this, you can build some pilot projects, find some domain areas, business problems, and the 6-month milestone is something to adapt and then build a curriculum out of it, and then in turns to come and collaborate in the field of generative AI. And then there are some resources which I have compiled, so you may take a look into it. And then if you want to get connected, here's my email and LinkedIn. So that's pretty much I have in theory. It's 7:15 my time. What we can do is we may take a 5-minute break. I'll be here. I'll just set up my system. If you want some water, you can go for it. We'll resume the first case study in 5 minutes. I'll just
Okay, after 5 minutes, we meet. As sir has said, after this theory section, sir will show the two demos, and before that, there will be a 5 minute break. Then we will start again after the break. Thank you.
Okay, ma'am.
Let's get started. So let me share my screen. So we can talk about the first application. So remember, I was talking about application of generative AI in content generation. So likewise, what I did was created a very simple workflow on content generation in healthcare. So what it does is that it provides different types of information. So to give you a quick background, you can generate information on patient education material, clinical documentation, some treatment plans, medication instructions, discharge summary, preventative care guidelines, and so on. So what it does is that whenever someone, let's say someone in hospital or a patient who is getting diagnosed, wants to get some information on a particular disease or a particular problem, then they can fetch that information here in this tab, and then it will generate a result in a fraction of a second. We'll use RAG, retrieval augmented generation, and to make it more sophisticated, I'm also enabling knowledge graph. So you can see on my left tab, I just is undergoing some treatments. Then what you can do is that you can fetch that person's medical information, and it will make the generated results more catered to that person. So we talk about personalized healthcare. So since we are just generating medical results, we are not claiming to be a physician or a doctor. So we would not. We would like to be ensuring that the results which are generated is just for education purpose. So these are some of the things which we can do. So let's get started. So I'm just from the audience, if you have a disease which you want to know about, you can type text in the chat. I'll just put that disease here. Someone want to unmute and tell? I don't see any text coming. If not, I can just use the disease. Let's see if you want to get some treatment plans on this cancer, and then we can sophisticate different ways in which we can add the prompt like zero sort, few sort, and chain of thought. So I'm going to use chain of thought learning, chain of thought prompting. The target audience is, of course, adult patients. And then in medical specialty, I can say oncology, because that's what we are focusing on. So with that, when I click this, go into multiple documents to find the information, you can get it right away in this app which I created for you. So the treatment plan for blood cancer. So it gives you an overview, what are the different treatment plans available, some more sophisticated information about this, like supportive care and all those things. And then it also comes with a disclaimer, as I mentioned, that this is only for education purpose and should not replace medical advice from healthcare professional. And you can, of course, download the content. So if you are a healthcare professional yourself, you can actually create a customized or a personalized treatment plan for your patient by fetching the details of your patient here, adding pre-existing condition, like here, existing condition you can add, and then some more information on that, like current medication and then allergies. And then you can also provide the information based on how much do they know about medical science. So if they know more, then you can increase the literacy level. Otherwise, you can keep it low. So you see that my result got changed or can be changed based on, as you see, the result, the type of answer which got generated changed a little bit. So you can play around with this, and also the type of model. So for this case study, you can add the latest LLM AI assistant like GPT-5 or Sonnet 4.5 from Anthropic. And then you can also play around these parameters. You can see the result which are generated, how sophisticated the results are. Another important thing which I want to highlight is I mentioned about some of the evaluation metric in large language models. So you see the evaluation metrics here in the tab, the readability, safety score, medical terms, how many medical terms are present in this generated content is something which we also want to focus on. And also this spider graph, which I'm showing you guys, also provides information on 4 metrics which I was talking of: accuracy, quality, safety, and structure. So you can see how do the generated result fare. So this gives you a great understanding of the type of results, the type of information getting generated using LLM. And then more analytics you can see from here. So let's say you are working on other medical condition. So you can take a look into, for example, we only talked about blood cancer. We can maybe add one more to give a fair understanding of this. I can say it's Alzheimer's disease. Let's see. And the assessment, because it's difficult to assess the Alzheimer's disease early on. And then this is not oncology. This is something which I would like to categorize into neurology. So let's check the result now. And now this time I'm going to make it very high. So let's see how the results there. So this is the result with a general medical disclaimer. So this is a general understanding of Alzheimer's disease symptoms. And then again, it gives you evaluation metric on how we are faring with the result which are generated. And then there are some other things which you can add in Alzheimer's. I actually used 4 medical portals to generate this content, SNOMED, ICD-10, and then there are 2 more. They are all available in National Institute of Health in the US. So those websites, their contents I used to generate this result. So I already used a RAG application here, but I'm just saying that if you have more documents, you can add here. So you see that the different types of results are changing there. So first we see Alzheimer's disease, blood cancer. So you can see analytics on this medical conditions, how it fares. So this is a very valuable result which you can take. For different type of users, you can provide different dashboards. So this is a consolidated and comprehensive dashboard which I'm showing you. If you are deploying it in hospital or in your website, then you can change the view which people look. For example, you can only show content generation and hide this analytics for the developer, and then you can show some more evaluation graphs here. So this is something which you can do. Also, one important thing which I wanted to add here is that you can add medical references here. So if you add medical reference, it goes into those medical reference and find more relevant answers. So you can take a look into the evaluation metric, and you see that the scores would change a little bit here. So you see the spider graph also changed. So this is something which you can. These are some of the applications which you can actually build using generative AI for medical or healthcare application. I only showed you content generation. There are other applications, risk rate in getting readmission. So how to quantify and how to actually send alert to the hospital and to their physician. So that is something which is also highly valuable for a big hospital, which is overwhelmed by many, like ICU or IICU patients. So it gives you a good track of the readmissible patients. So that is another application which you can work using this type of platform. Any questions so far? Yes, no? Okay. If not, then we'll take maybe 2 minutes break this time. we can get started again. So this second case study is on insurance. So to again give you a background, let's say if there is an accident and there is insurance in a particular car or in a particular vehicle. So the usual process is that the car is evaluated by a person called claims adjuster from the insurance company, and then they make multiple documentation. They evaluate what type of damage has been done, and based on all those, they gives you some claim amount after processing your car and all those things. So this whole process takes about 2 weeks, roughly in the US. It takes about 2 to 3 weeks. So this particular application in generative AI actually can perform this task in less than 20 minutes. So we'll see how it works. So in this, what we are doing here is that I was talking about agentic AI. So I have created a series of agents in MCP and A2A. So let's say if a crash happens, so there is an app, a victim actually opens the app and logs, saying that they met an accident. So then once this event initializes, a series of AI agents like telematics agents, which are the different types of sensors installed in the car, gets activated. So all the data are being captured, and then the patient also takes, the victim takes some photo of the car at the site of accident for visual assessment in the app. And people claim accidents which has not happened. So we want to evaluate whether it's a fraud claim or a genuine claim. So there is a score which I'm going to show you, which will evaluate whether there is a fraud or not. And then once we find that it's a genuine case of accident, then the visual assessment agent passes on to logistics and repair agent. And then once that is evaluated, finding the different cost of repair, it goes into the settlement agent, which provides a settlement value or a claims value to the customer, to the victim. So that is how the entire process works. So these agents are actually using MCP and A2A to talk to each other and to perform the entire series of actions. So let's see this in live. So since we are simulating this process, I don't have a real accident data right now. So what I'm going to do is that I'm going to initialize. So the first step is to initialize, meaning that when accident happens, someone opens the app and activates the button. So that is what we are doing, is to initialize. So as soon as we initialize, you will see that on the right side, the offline system will get activated, and you will see that it says system online. So now we can work on this app because our system is online. So what we are going to do is that since we don't have a real accident data right now, I'm simulating a crash event. So right now, if you see another dashboard called Agent Monitor, you have all the agents running, but you don't have any claims data to process. So what I'm doing here is that I'm creating a dummy data by simulating a crash event. So as soon as I do that, you will see that data is getting generated. So there is a customer name, vehicle status, and the stage in which it is getting processed, and then the timestamp and the claim ID, which are important. I will generate a couple of more crash events. So there are 3 accidents which I'm taking a look into it. So you will see that it generates all the key information about the victim's information. And then there is another thing which I wanted to show is that fraud detection agent is working on pattern analysis, anomaly detection, and then historical comparison across the insurance companies and risk scoring. So we want low risk scoring victim to be identified as the genuine claims person. And then let's take a look into this thing. So the first thing I would like to show is that if you go back to the overview, you see that all of these agents are connected to each other. So we'll go into the analytics tab. It's in this way. So if you are an executive of this insurance company, you would like to see how much claims have you processed, what is the severity of the claim, and how much time it takes to process each and every claim. So as I was mentioning, typically most of the claims are processed in under 10 minutes. Maximum it takes 15 minutes. So it's far less than 2 to 3 weeks which a human takes to evaluate a particular claim and disburse the money in a insurance account. So we see that using this app, you can actually cut down the time by many folds. You can do this entire thing in less than 30 minutes. And then as an executive, you can see all of this dashboard to understand how much claims has been processed, if there is any fraud or not. All of this key information, you can take a look into it. And then there is something known as detailed information about the victim. For example, you can see something known as crash data. So the point, what is the nearest auto store, what is the nearest towing company near the accident which has happened, and you can pinpoint providing claims, but also providing fantastic customer service to your insurer. So minutes. And also, since the result which I generated has dummy data, so I created some dummy cities like Houston in Texas, and then these are the different impact and telematic data which are basically sensors information in the car. So all of those are getting captured, and then we have a database where it goes getting compared, and then the customer, so all of those are simultaneously compared in the background. Within a fraction of a second, you will see that the claims will be processed. And then there is another thing which I wanted to show you. So this dashboard is the consolidated dashboard, but there is another dashboard called agent monitoring dashboard. It shows the health of each and every agent which I created in this particular process. And then there are more granular level of information which you can assess. What is the health of each and every agent which we are seeing, for example. So this all things can be checked into, and these are all the claims which I have ran in this app so far. So you see that it gives the type of are getting activated in what timestamp. So all of this information can be highly valuable for data processing time. So you see that the processing time can be within a fraction of minutes. So 2.3 minutes, which is like less than 5 minutes. And then there is another dashboard which I created for the executives, which shows consolidated information about the different type of business goals. So number of claims processed, what time of day, how much time it took, and then also how different agents are performing, what is the accuracy rate of different agents. So if our fraud detection agent is less active, then how can we make it more and more intelligent? Also, a lot of cars do not have sensors data. So how to make more and more sensor data available to this type of app is something which we can work on. And these are the recent claims which I ran this app and found. So you see that some of them are settled, the amount, and how much time it took. And all those type of information you can export as well. So if you hover into it, you can go and export this information. And also you can customize the dashboard based on what type of information you would like to take a look into it. So this is a very sophisticated dashboard which you can build using generative AI involving agentic workflows in MCP and A2A, which helps to complete this entire claims processing within 20-30 minutes of your time, and can save a company at least $10 to $20 million per year in resource cost, in human cost, and also in compute cost. So these are all the things which I wanted to show. I will stop here. Actually finished 15 minutes before. So if you have any question, I'm here to answer. Someone texted something. Break for 5 minutes. Okay. Yeah, we took a break at that time.
Any questions
I'm here to answer any question if you have. If not, you can reach out to me my email. I'm going to send you a
Yes.
public link to my presentation. So take a look into it if you feel in future. For
Yes,
any
sir.
questions or
Any
could address
questions
me
from the
mail.
participants? Yes, sir.
No question.
Yes, maybe there is no question currently, sir. But
No
maybe
problem.
you can share your email ID if they can want to know more or any queries.
Okay. Sounds good. Thanks again for inviting me. And
Yes,
if you have any thing to discuss in future, you can find me in LinkedIn as well.
yes, sir. Yes, sir.
It's the
Yes.
link to my LinkedIn is in my presentation deck.
Yeah. Okay, sir. Okay. So, if no doubt, okay, we can conclude the session. So, thank you very much, sir, for your enlightening and thought-provoking session. Your talk has truly expanded our understanding of how generative AI can move from theoretical exploration to real-world impact. And also the your practical examples and industry perspectives have provided us with valuable insights into applying the AI technologies effectively across various domains in whether in healthcare or in insurance. So, and we sincerely appreciate the time and effort you devoted to share your expertise with us today, sir. So, on the behalf of organizing committee and all participants, I extend heartfelt gratitude to you, sir, for your valuable contribution to our FDP. And we hope to have the privilege of learning from you again in the future. And no, there is a vast time difference. It's early morning for you, but you shared your 1.5 hour for us. So it's a great, sir. Thank you for joining with us and giving your time.
It's a pleasure. Thanks again for inviting me.
Yes,
All the
thank
best
you.
for everyone.
Thank you, sir. Thank you.
Thank you, sir.
Bye bye. Take care, guys.
Okay, so participants, I'm sharing the feedback link in the chat box. And yes, according to the schedule, this is our last session of the FDP by Mr. Vivek Verma, sir. And the online test will be concluded tomorrow in the evening time. And now it's time for the conclude the session. And for this, as we came close to this Atal online 6-day FDP program on emerging frontiers in AI and machine learning for next generation engineering applications, it gives me pleasure to extend a sincere thanks to all of you who made this program a great success. For first and foremost, our gratitude to all our speakers and resource person for sharing their valuable time throughout the sessions, and obviously the interactive sessions and the practical perspectives which have greatly enriched our understanding of fast evolving world of artificial intelligence and machine learning. And a very special thanks to all the participants for your active involvement, curiosity, and the enthusiasm you showed during every sessions. Your engagement, the thoughtful questions, queries, and the feedback has made our FDP truly interactive and meaningful. So thank you everyone for joining with us in this 6 days FDP program. Now I would like to call Miss our organizer, ma'am, that's Dr. Shimpir Alhan, ma'am, to share a few words with us, with all our participants.
Good evening, everyone, and thank you, Swati. You have been the key for this FDP of 6 days. So I would like to take this opportunity to express my heartfelt gratitude to all who made this 6 day journey truly inspiring and impactful. And on behalf of the Sri Shankaracharya family, I extend our sincere thanks to the Atal Academy and our deepest appreciation to all the eminent resource persons from the academy and the industry who shared their vast knowledge and expertise on cutting edge topics such as deep learning, generative AI, NLP, responsible AI, and their use cases in the industry. Really, it has been really a marvelous thing. So, as in the afternoon, we have seen that how the blooms and billets are processed in the mill. So, special word of thanks to our respected director, Sir Dr. P.B. Deshmukh, who has been a source of constant encouragement. And we can't thank enough our chairman, Shri I.P. Mishra, sir, for his leadership. I also extend my appreciation to the co-coordinator of the program, Dr. Ajay Verma, sir, and the entire organizing committee members and the technical team for their dedication behind the scenes. Of course, you are there. Professor Chiranjeev sir is there, and entire organizing team. So finally, to all of our participants, thank you for your enthusiastic, insightful, enthusiastic participation, insightful questions, and commitment to learning. So without your active involvement, this FDP would not have been possible. So with this, officially, we conclude the FDP. Wishing you all continued success, innovation, and collaboration ahead. And with this, I thank you all. Have a wonderful evening. But before making an end to this meeting, as Swati madam has already told many a times that we have got many concerns in the group. But this test for the FDP is scheduled tomorrow automatically by the portal, and the time of this FDP every day has been scheduled from 6 p.m. So the test will be live tomorrow at 6 p.m. and so please attempt the test as it is mandatory to earn the certificate. And if you have any queries, you can please ask me now, or you can just post in the group and we'll be there to answer them. So I guess everything is good.
Ma'am, my name is Neha Tripathi. One day I was unable to attend the meeting because of health issues, ma'am. So please consider it.
Ma'am, 80% attendance is must, so it will be okay if you have attended other sessions.
Yeah.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Okay, thank you.
Ma'am, for today, I was in the exam duty, ma'am. So I could not see the message in the WhatsApp. But when I got to see the message at 5 p.m., after that I have.
We will consider.
So,
Okay, now it's yes, ma'am. Yes, ma'am.
so
Continue.
let's conclude the FDP, I guess.
Thank you so much, ma'am.
Thank
Rajkumar
you.
Jhapte here.
Yes,
Yes,
yes.
sir.
Swati madam, thank you so much
Thank
for
you.
completing this FDP in a very well organized manner, ma'am.
Thank you. Thank you for
Timely, all the things have been happened timely. I'm seeing ma'am in corporate look.
Yeah, yeah, Shimpi ma'am. It's Sunday, na?
Sunday, but today itself she is in.
that, I'm sure. Soon.
Yes. Okay. Thank you very much, ma'am.
Thank you, everyone. Teamwork and with all members, this would not have been possible.
Yes, ma'am. Obviously.
Thank you, participants. Have a very good evening. Okay, bye.
Okay. Thank you, ma'am. Okay, thank you, everyone. And now it's we are ending the meet here. If you have any doubt, please be in touch in the WhatsApp group, because all updates we are sharing in the WhatsApp group only now. Okay, so thank you all, and we are ending here the meet. Ending the meet here. Thank you, everyone. Good evening. Have a happy Sunday now. Sunday evening.
Okay, thank you, ma'am. Thank you so much.
Thank you, sir. Thank you. Yes, good evening.
Thank you, ma'am. Thank you.
Yes, sir. Mama. Papa.